find more equations than just the starburst one, but we are going to start with the starburst one, of course. But I need to give you a definition for this. So we're going to start with the top least squares regression line. And you're going to see that. So we talked about regression yesterday. Regression is using a mathematical model to make a line of best fit. There's a lot of different ways to make a line of best fit, as we talked about, like you're in middle school or science, whatever they say, put as many dots above the line as below. Like that's one of the ways. It's completely inaccurate, but that's fine. The agreed upon one that is used in most studies and all of statistics is called least squares regression. Okay, so what does least squares regression mean? I want you guys to open up your packet real quick. I made you a picture. There's no notes for you to take or anything. I just made you a picture. Mrs. Salva, you made us a picture? Yeah, I did. Okay, so I felt like I really wanted to tell you what least squares means. And it's these two Desmos graphs. Okay, so take a look at these two Desmos graphs here. There's nothing for you to do. These are just for your reference. I just made them for you. This is a scatter plot that I made up. And I put in a line of best fit. Okay. Now, can anybody tell me two attractive things about this line of best fit? Why, as a person who would be like studying and doing stats and would be like trying to make a mathematical model, what would be attractive about the line that I made here? There's two very specific things. It has a slope of 1. Isn't that convenient? And what else? There's one more. What does it go through? Yeah, it goes through the origin. Okay, we would be really tempted to throw a line through the origin with a slope of 1 through these points, because that would be easy for us. Okay, but what I want you to see is that I have squared the residuals. Okay, so we're going to have to break that down a little bit. Do you remember the residuals are vertical lines? We drew one yesterday. We only drew one because I didn't want to like mess up the whole graph. It would be like all overlapping. And what I did was I legitimately squared it. Like I got the length of it and I squared it by making it a square. Not, I did square the number, but I legit made it a square. Okay, so this is 1 squared with the area of 1. This is 2 squared with the area of 4. But I did it as a visual thing. Okay, so now notice I did this calculation, which we're going to talk about later, but this is 1.3229. Okay, now flip to the other one that I made for you. Oh, Mrs. Talbot, you're making us graphs in your free time. What a nice lady you are. Okay, this is actually the proper least squares regression line. Okay, and what I mean by that is you're like, but there's 5 squares, not 3. Okay, but the area adds up to less, which means less error. So all of those areas that I've shaded in those squares, those are errors. And you want the least error. So this is called the least squares because it has the least amount of error. Okay, and the way to get that error is this, but I'll come back to that later. It's basically like standard deviation. So you take all of the areas and you divide by how many numbers minus 2, and then square root. Back to that later. Okay. So that was for my visual learners out there. I'm going to call this the LSRL because I'm a lazy human being, but also the College Board calls it the LSRL because we just can't say least squares regression line. We just can't do it. I just possibly cannot. So this is the line of best fit that minimizes, so means smallest, the sum of the squared residuals, which means their areas, the sum of the areas when you make the residuals into squares. Okay, and it's really tedious to calculate all of those residuals and square them and do that work. Your calculator will do it for you, and I'm going to teach you how to do that. So anyway, this is the moment. So grab your calculator. I'm going to teach you how to find the least squares regression line on your calculator. You also need your Starburst graph. Okay. Here we go. Following the order of commands. Second. You know what a second button is? Okay, 0, that's a 0. And then this is X inverse. It's located over here right underneath the math button, like fourth button down. Okay, and then you need to scroll to diagnostic on. Yeah, sorry, I made it a 0 because otherwise it would look like an O if I didn't have the line in it. I don't know. Okay, scroll to diagnostic on and then enter, enter. Okay, that piece right there, if you are using your own calculator, you will not have to do that again. That's just like a one-time deal. It's turning a feature on in the calculator. If you're using one of my calculators, who knows what one you're going to grab out of the tray, so you might need to be able to do this again, but you have it in your state. If you reset your calculator or the battery dies, like full-on dies, you might have to reset it also or do this again. But most of the time, you won't have to. Okay, now, stat, back to stat, that's your favorite. Enter. Okay, and you're going to put all of the X's into L1 and all of the Y's into L2. Now, I've got stuff going on here, so I'm going to scroll up to the top, clear, enter. Scroll up to the top, clear, enter. Okay, and then you're going to enter in the hand lengths into L1 and the starbursts into L2. And go slow and careful. I'm already halfway through the list. Yeah, honey. It'll still work, but let me fix it. You're gonna have to do the thing again, the diagnostic thing. do for you really quick. Children messing with the calculators. I blame math three. One of my calculators is missing. I'm not happy. I almost put 25 in for Colby's. All right. Two. Are you guys close? Okay, so now we're here at this set of directions. Go back to stat. Scroll over to calc. Now I want to pause here real quick. You know how like first chapter we did a lot of one variable stats? We did that over and over. You can do two variable stats. You could do it right now if you just want to see, because we're working with two variables. If you hit two variable stats, trust me, it's not going to hurt anything as long as you have your L1, L2. What it'll do is it'll give you the one variable stats for the X's, and then it'll give you the one variable stats for the Y's, which is kind of cool. Just so you know, that's there. We're actually going to use that tomorrow, but that's not what we're going to do. Okay, so stat, calc, and then you want to go, you want to hit 8. You can scroll down to 8 if you like, but I like to just hit the 8 button because I'm lazy. And this is linear regression A plus BX. You want to make sure that the X list says L1, the Y list says L2. The other things are blank. And then enter, 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 calculate. Okay. And there is your line of best fit. Okay, so what you do, you already know this from your, we already wrote it on our graph, but we're going to write it here also. So y equals A plus BX. Okay, so now you see what I did on my prep period when you guys all got your Starburst data and you brought me the pages, and then I sat and typed those into L1 and L2, and then I got your equation. So that's what I did behind the scenes for you guys to get the stuff that we wrote down on our Starburst paper. Now you're all up to date. Okay, so that's that. We actually have three pieces of the lesson today. That's the first one. And the second one really requires us to have that data in there still. And it's still very much calculator based. So I'm going to move this down and then you can set up the bottom half of the paper. With a lot more calculator instructions. And this part is actually really real for your class. I don't know how this is going to come out because I kind of feel like maybe your graph is a little nonlinear. I'm interested to see how this is going to go. Mystery. Okay, so The next thing we're going to learn about is form. Okay, so we did direction. How can you figure out the direction? There's a bunch of ways. You can tell from the graph going uphill. You can tell from the slope is positive. You can tell from R being positive. Do you guys remember what R is? It's really important that you remember what R is. That whole thing we did on Friday where I showed you the slide and we had the graphs and it was like percent of strength, like 0.3, 0.8. Well, ours was 0.6. On the starboard side, 0.6. Okay, so we said moderate. Okay. So we talked about direction. Outliers, there's not a thing. There's no rule. It's just like you just say it. We talked about strength somewhat. We're halfway through the conversation of strength. Strength was R. That was strong, moderate, or weak, depending on the looking at the graph and also comparing it with your R value. And then now we're going to talk about form, and we're going to try to make a better decision about something being linear or nonlinear, and that's what residual plots do. So you need to know three things about residual plots, and then we're going to make ours for our starburst data on the calculator. And I'm really interested to see how that's going to go. But anyway, okay, so it's a scatter plot. Of the explanatory, which means your x. So whatever your x is, what's our x in our problem we're working on? Hand length, right? Okay, so the x-axis is going to be hand length versus, and so I mean versus like the y-axis is going to be the length of the residuals. So how far away they are from the line of best fit. If that's hard for you to imagine, you can think of it this way. It's the original scatter plot rotated and zoomed in. So that's like kind of our iPhone way of looking at it. You take your original scatter plot, you rotate it, and then zoom it in. That's kind of what a residual plot is. Okay, and this is what you're looking for. No pattern and even scatter. No pattern and even scatter is a good thing. I know it's weird in math. I always tell you to like look for the pattern. This is what we do. Good mathematicians, the best mathematicians are the best pattern recognizers. This particular thing goes against the grain. It's looking for no pattern. So you want that baby spaghetti situation. Okay, now I don't love the CPM book for stats. I don't use the CPM book clearly. We use something else. But there are a few things that I like from the CPM book. So I actually ripped a page out of it. I didn't rip it. It was in a binder. I'm just saying that for effect because I like this one page. So I'm just going to show you this page from the CPM text. And this is an actual problem in the book. And you were supposed to talk in your groups for 10 to 15 seconds about which scatter plot goes with which residual plot after what I just told you. You see in your mind, see if you can match which scatter plot goes with which residual plot. I hear you saying all the right stuff. You got it. You definitely have it. Okay, so this guy right here, scatter plot 1 goes with residual plot C. Okay, and what I want you to notice is that at the first part of the line, they're tight, the scatter plot's tight with the line. But then as you go down the line, it gets more spread out. That's called a fluted pattern. That's bad. Fluted is bad. And I'm kind of worried that your data was fluted. I don't know if you want to take a look at your scatter plot. But this is what I fear our residual plot might look like. Okay, but can you, with your head, everyone take your head, physically, turn your head so that the line of best fit is now the x-axis. See, that's what happens here. Yeah, you gotta like turn your head 45 degrees. Okay, now see this one's like all evenly spread out. So that one goes with B because this one's evenly spread out. And that one above the curve, below the curve, above. And this is above, below, above. Okay, so think of this like you're a detective and you're like with a microscope trying to look for clues. And so this is one of your tools that you can use as a detective to be like, oh, is this linear or non-linear? Not really sure. Okay, so what they're doing is they're basically taking it, turning it like this, and then zooming in. Taking it, turning it like this, and zooming in. Turning it like this. And the zooming in really accentuates the pattern for you so you can see it easier. Exactly. It's exactly this, just zoomed in. Okay, so let's do it with ours. Let's see what happens. I really don't know what's going to happen. Okay, so here we go. This is complicated. So now is not the time to lose me. Stat, enter. Okay, so go back to where your lists are. And this is something that I'm sure probably no one in this class has ever done before. You're going to put the equation into the top of L3. You might have not even known that your calculator was capable of putting equations up in the list, but what you're going to do is put the equation at the top of L3. However, you have to put L1 in for X. It's going to plug L1 into all of those values. It's going to plug that X in for you. Okay, so you're going to go to the top of L3, negative 4.8 plus 1.6. Okay, and I don't want to put X. These are the X's. I want to put L1. Notice above all of the numbers, it gives you the lists. L1, L2, L3, L4, L5. So second one. So negative 4.8 plus 1.6 X. And it's going to plug all of those in like 1 second. So hit enter, and then it's going to very satisfyingly fill in all of the plugged in. It does all the function machines for you. Look at that. Isn't it beautiful? All that math that it did in 1 second. Okay, now, next step. Put L2 minus L3 into the top of L4 because that's actual minus predicted Y. This is actual Y minus predicted Y. What's the formula for a residual? Actual Y minus predicted Y. L2 minus L3. Actual minus predicted. And then hit enter. And those are all of your residuals. Okay. Now, once you have that set up, go second. Y equals. Enter to go into your stat plots. Go to the first one that's a scatter plot. And instead of doing L1 and L2, you need to set it up to do L1 and L4 because it's doing the X's and your residuals. And then zoom 9. Ah, there's my fear. Yeah, our graph's not too good. That means our form wasn't really super linear, which I was fearing, but that's okay because we're just going to pretend and keep going on with life. Zoom 9. Do you have Zoom 9? Did you put the things in? The things in? Did you do all this stuff? And then you did this? Did you put L1, L4? Yeah. Did you make? No, you probably have stuff in your white. Are you letting him ride in the backpack without the cover on? I said, are you letting him ride in the backpack without a cover on? Okay, this is why I video all my lessons, so you can go back and fill it in. So we have two pieces of the 3 that we need to learn today. Those are the 2 fun ones, sadly. What? Yeah. The last piece is 2 more sentences. I know, it's the worst part. So let me give you another second to make sure you're situated. Then we're going to learn 2 more sentences, and then we're going to write our 2 sentences on our starburst graph. For those, we're going to fill in the blanks, and then we're done. Are you ready? What? Yeah. Other than I have to say what the things are in the stick. Okay. Yeah. Yeah. This is the end of the need of paper. chair like 3 times because I was excited about teaching. But look at me, I made it this time, not hitting anything. Okay, you guys, let's fill in the, hopefully you left the lines that I put there. Tell me you left the lines. Okay. All right, so standard deviation of the residuals is the typical length of a residual. Okay, and there's a formula for it, which is extremely unhelpful. But I'm gonna give it to you anyway. Okay, and it's much more helpful if you look in your packet at the Desmos graphs that we just looked at, where I had the square shaded in. You can see how I calculated S much easier on your packet than you can from this formula. But for those of you who've taken calculus and stuff, it's just the square root of adding all of the residuals squared over the amount of points minus 2. But in my on the packet, I made them areas for the amount for the residuals squared, so it'd be easier to see. But basically, that capital sigma, just add them all up, whatever the residuals are squared. So I made them into squares over n minus 2. I'm not going to ask you to do this. I am going to do it on my calculator just to see what S is for our graph because I'm interested, but I'm not going to ask you guys to do this right now. And then there's a sentence for it, which we're going to write for our graph on the pink paper. And then the coefficient of determination is R squared. And this is so funny to me, but if you read a study, R squared is going to be capitalized. R squared is literally R squared. Like the correlation coefficient that we learned about on Friday with the slides, it's literally just the square of that. But for some reason, when you read it in studies, they capitalize it, and then you think you're doing something wrong. And this is in lack of better words, how much X and Y relate. Okay, so what I mean by that is, what about those two variables specifically relate? How much of it goes together? And then how much of it is other stuff? And we haven't even talked about the other stuff yet in this class, but what else? I'm sure that you guys must have thought about what else could determine whether or not somebody picks up a lot of starburst versus their hand length. Like what's another thing? Sure, technique. What else? What? Fingernails? Ooh, nice. I didn't even think of that one. What else? I'm thinking of one really important one. Grip strength. I didn't even think of grip strength. That wasn't it. Amazing. I was actually thinking of palm size versus finger size. But do you guys feel like there might be more than one thing that's contributing to whether or not someone picks up with arbors? Okay, so R squared is telling you how much of that is just handling, and then the rest of it is everything else. Okay, so take a look at your pink paper. What was our R squared value? Okay, so 36% of the relationship can be explained by hand length. That means that 64% can be explained by other stuff, other variables. Okay, so we're gonna finish this up. Pink page, last thing. Okay. We're gonna write the two sentences for these and then we're done. If you need to, yeah, you can, yeah, go totally. Hold on. How many points were there? 30? Okay, wait. I forgot a step. Okay. Square root. Okay. Does that look right? So this was the residuals, right? Square them, add them all together over n minus 2 square rooted. Okay, so 4.78. All right. I'm going to add that up here, by the way, in my little spot. Okay, just write R squared interpretation here, and then I'll start with this tomorrow. Just leave yourself a spot for it, and I'll start with that tomorrow. It's no big deal. Tomorrow's notes, I think, are actually shorter than today's. So, and that's a block day. So I'll be fine.